Alright class, so what we're going to do is take this one step further and analyze our problems in a different sense. And so we're not just going to find the derivative, but find out different pieces that are important to our graph. So according to this, it says find all points, if any, at which the graph of the equation has a horizontal tangent line. Write an equation of each horizontal tangent line to the curve. So what I need to do is to make sure we review what it means to be a horizontal tangent line. So in order to be a horizontal tangent line, I'm going to have a curve that looks like this, right? And what we're going to need is to make sure that our curve has a tangent line that looks like this. And in calculus, that means my derivative has to equal 0. And as you've noticed, with lots of our implicit differentiation equations, we typically get fractions. Well, the only way to get a horizontal tangent line is if I set my numerator equal to 0. So let's go ahead and find our derivative and then set our numerator equal to 0. So if I take this derivative, I get 8x plus 2y dy dx minus 8 plus the derivative of 4y is 4 times dy dx plus 0 is equal to 0. So let's collect our like terms, and if you notice, I get a 2y plus 4 because of this here and this here, dy dx equal to a positive 8 minus an 8x. So my final derivative is dy dx is equal to 8 minus 8x over 2y plus 4. So that's our derivative, but like we said, now I need to set my numerator equal to 0. So if I set this numerator equal to 0, I get 8 is equal to 8x, and if I divide by 8, we get that our x is actually equal to 1, right? So I get x is equal to 1. So according to this, I need to find where this happens. So what I need to do is I need to find the matching y value. So if I have x is equal to 1, how can I find the y values that match this? Good, I'm going to take this and plug it back into my original equation. So let me go ahead and take this down. Let's plug in 1 into our equation. So I'm going to get 4 times 1 squared plus y squared minus 8 times 1 plus 4y plus 4 equal to 0. So I get 4 plus y squared minus 8 plus 4y plus 4 is equal to 0. Well, if you take a look, 4 plus 4 is equal to 8, but I need to subtract this 8. So all of these will end up canceling out. Let me add this 0 right here. So now let's solve this. Let me go ahead and scroll down just a little bit further. I end up getting y squared plus 4y is equal to 0. So the only way to solve this is if I factor. So I get y times y plus 4 is equal to 0. So my two y values are y is equal to 0 and y is equal to negative 4. So our 2 points are at 1, 0 and 1, negative 4, but the equation's asking for where the horizontal tangent lines occur, and so those 2 places are whenever my y is equal to 0 and when my y is equal to negative 4. Good, so let's go ahead and take a look at the next problem. But what I want to do is I'm going to copy and paste our derivative that we found. Okay, so let's go ahead and do this. And it says, for all points if any, find all points, if any, at which the graph has a vertical tangent line. Write the equation of the vertical tangent line. So just to draw a picture and to make sure we understand what a vertical tangent line is, I'm going to take my pen. And a vertical tangent line is any time I have a graph like this and I notice the line is vertical up and down. So if I want to find something that's undefined, or a vertical tangent line, what do you think I need to set equal to 0 for the derivative? Well, according to our last problem, I can't set the numerator equal to 0 because that gives me a horizontal tangent line. So where's the only other place I can set this equal to 0? Good, the bottom, so the denominator. So I'm going to set 2y plus 4 equal to 0. I solve for y. I get 2y equals negative 4, and that gives me y is equal to negative 2. So once again, I need to make sure this works out. So I need to plug this y equals negative 2 into our original problem. So if I plug that in, I get 4 times x, oops, sorry, let me undo that just to write it properly. I get 4x squared plus y squared, so negative 2 squared is 4, so plus 4 minus 8x plus 4 times y, which is negative 8, plus 4 is equal to 0. Once again, 4 plus 4 is 8, but I have to subtract off that 8, so these cancel, and what I get left over is 4x squared minus 8x is equal to 0. I need to factor again, so I get 4x times the quantity of x minus 2 is equal to 0. So my 2 points, or my 2 vertical tangent lines are when x is equal to 0 and x is equal to 2. So these are the only 2 areas that I will receive vertical tangent lines. Perfect. Let's go